which means the radius is 5. The volume is the volume of a cylinder because it's in the shape of a cylinder. And what we're going to get is pi times 5 squared multiplied by your h is 450 pi. The pi's cancel on both sides. I'm going to get 25h equals 450, and then how does that divide in? 18. Okay. H equals 18. Right. Just get it right. I'll look at it later, right? A small candle is in the shape of a cone, has a volume of 12 pi centimeters cubed. A large candle, also in the shape of a cone, has a volume of 150 centimeters cubed. The height of the small candle is h, and the height of the large candle is 2h. The large candle has a radius k times that of the smaller candle. Work out the value of k. That's wordy, all right? Nothing to suggest they're similar. Does it say they're similar in dimension or anything like that? See, if they were similar, double the radius, double the height would mean double the radius, and we wouldn't even have to work out k. Then we just know that k is 2. So I'm thinking we just stick with our keywords here: volume, cone. So I'm just going to write down the volume of a cone formula. Would be a very good start off. Okay. Next thing I'm thinking of is the small cone has a height of h. The large cone has a height of 2h. Okay. And then the small cone has a radius of r, but the large cone will have a radius of kr. Yeah, that's what I'm thinking. And I think I'm just going to insert. I'm going to plug them into both equations and see what happens. Nothing else I can do other than highlight keywords and fill in the data. Okay, and then I'll figure it out from there. I've never done this question actually, so this is a new one for me. So here we go. So 1/3 pi radius squared, capital R I'm using for it, just the small r's look weird for me, and then h. Okay, and then we equal 12 pi. I'll cancel the pi's, and I won't do anything else because I honestly don't know what I'm doing yet. I'll do the same thing for the larger circle. Yeah, I'll know. It'll come very clear to me in a second. It's just going to come very clear to me in a second what I'm actually doing. Okay, and then we get 150 pi. I made a mistake there. What's this? I've got the 2, didn't I? 2h. I've got the pi and the 2h. Jesus. No. The lads are saying I'm going to see now, which is quite true. Now, the pi's cancel. Okay? And I'm going to get kr multiplied by another kr, yeah? So it's going to be 1/3 k squared r squared. And there's that 2, isn't there, as well? I'm just going to multiply the 2 by the 1 to make that 2/3. Okay? And I'm going to lob the h at the end, and that equals 150. Now, what I'm thinking I can do here, see the first equation? See the equation at the top? I'm thinking I can figure out what r squared h is. What is r squared h if I brought that 3 upwards? 36. It's division on the left, which will make it multiplication on the right, yeah? And the h. Thank you. It's great having you here. Now, what can I do with this r squared h? Sub it out with, yeah, replace it with 36. And then I think I'm in business then, because it's going to be 2/3 of 36. Don't forget your k squared equals 150. And then 2/3 of 36 is actually 24. 24 k squared equals 150. And then k, what's 150 divided by 24? 6.25. Square root that into 2.5. The k value of 2.5. A third conical candle has a curved surface area covered in clot. Now I see the word curved surface area. I'm going pi r L. Ever see that? I'm just plucking that formula down from the notes. Pi r L. The net of the clot is shown, not the scale. This net covers the cone perfectly with no overlapping material. In the diagram, OBA is 216 degrees and OA is 8, so the radius is 8. Find the length of the arc. Now, if you guys remember correctly here, okay, I'm just going to draw a cone just to show you what I'm talking about. So I'm just going to draw a cone here. Okay, and here's my cone. Now, what we're looking at is this clot section. When we fold that clot up, so all this like blue part here, what that does is it makes basically like the wrapper of a cornetto. That's what it's forming. Okay, so that 8 is actually the slant height. Would you agree with that? So that 8 is the slant height. Okay, and guess what the arc is? Does anybody know what that red arc is? When you fold it up, it's actually the circumference of the circle at the bottom, and that's what we would have learned from the mock the other day. So we're following through on what we learned there, and we're hopefully going to do something good here. Now we're going to go for the formula length of an arc, yeah. So theta over 360 multiplied by 2 pi r. That one, yeah. We're not using the radian one because it's not measured in radians, and we'll go 216 over 360 multiplied by 2. You can leave out the pi if you want because you need it in terms of pi, and then 8. So everything but the pi should do the trick. Anybody got an answer for that one? Okay. Anybody got an answer for it? 48 over 5 pi. Anybody confirm that? Grand. All right. Now, to be fair, it is CM, so he's usually good. Now, is this the next one? Is there part 2 to that? Or? We have to get the radius of the cone. All right, so that's handy, all right? Because what did we say about this earlier? 2 pi r is the circumference of the base of the cone, and it actually equals 48 over 5 pi. The pi's cancel out, right? And then just divide 48 over 5 divided by 2, which is actually 48 over 10, which is actually 4.8 centimeters. Now, the spherical ball of wax is used as a candle. The radius is a sphere of 2.7 centimeters. Find the volume of a sphere. Even if you got nothing else right here, you can get this right. Just a formula. Yeah. What year again? 2022? Yeah. That was a nice one, shall we say. Who knows? All right, so we throw all that in to 3 decimal places. What do we get? 82.448, right? And we can see we're in business there with the marking scheme, okay? And try and remember your units. There's nothing to say that you don't get dock marks for the units, but just always put in the units if you can remember it. Okay? Now, a horizontal slice is cut off the sphere so the candle will balance on level surfaces. The area of the circular base of this candle is 5.4 centimeters cubed. So if you actually imagine that, when you cut like an orange, if you slice an orange, the cross section is still a circle. So there's actually a circle here. I'll do it as a. Can I make that work? Like a glove. No, we all see that. Now that's a circle, not an ellipse. It's just a 3D diagram. Okay. What's the area of said circle? 5.4 centimeters, right? So what I'm thinking is, I'm going to sub that into the area of a circle for me. Okay. And I'm going to say radius squared is 5.4 over pi. And I'll just find that radius now for myself. Root answer. We got 1.311. Now, what I'm claiming is that 1.311 is the radius of that bottom circle, which is here to here. 1.311. Okay. Find the value of L, the vertical distance from the top of the candle where the cut is made, as shown in the diagram. L has to be bigger than 2.7. Give your answer correct to the nearest millimeter. Okay. Is this the old sphere? The sphere we just did in the last question. And what's the radius of the old sphere? 2.7. So if you imagine the center of the sphere, I got it. Standard one. I imagine that's the center of the circle. And what can we say about here to here? There you go. 2.7. What we're going to do is we're going to find the green length. And then we're going to add the green length to the purple length. But we already know that the purple length is 2.7 because it's a radius. Yeah. So we're just going to Pythagoras that for the green length. And I think we're in business. That's a nice question. 2.7 squared equals x squared plus 1.31 squared. X squared equals 2.7 squared minus 1.311 squared. And .57 square root that. We got 2.36. Yeah, I'll do that now. So what did I say it was earlier? 5 point something. We all know how to get that now, don't we? So 2.36. We've got to add that 2.36 onto the 2.7. We've got a 5.06. Cool. So just while we're here, I said 5.06. Is that 0.6 centimeters though? Correct, nearest millimeter. So that is technically 506. No, that's 50.6 millimeters, which means I have to round up to 51 millimeters, which is actually 5.1 centimeters. It'd be a shame to lose. So, however, logo of the company is shown A, B, C, D is a square, great, 30 by 30. The points E and F are midpoints. So what they're saying is that that's the same length as that. And we know all them are the same length then, don't we? So what we know is that AF is the same as FD is the same as AE is the same as EB. We know all of them are the same. Okay, they're all 15. Okay. Okay. The lines EC and FB are perpendicular. That means Pythagoras' theorem is a go, because they're all going to be 90 degrees, aren't they? Okay, so Pythagoras' theorem or sine SOHCAHTOA is in play. Okay, next thing. Using similar triangles or trigonometry, find the length of EO. So we call EO X, so X is our target, yeah? Okay. Now, similar triangles. Right. I think I have an idea. Okay. I know a lot about this triangle here, don't I? See this big one? I'm going to shade it in now. The one I seem to know the most information about is this one here. What do I know about this one? I know 15 and the 30, don't I? Yeah, so that's I'm thinking that 15 and the 30. Okay. All right, now can I prove that it is in fact similar? And I can get Pythagoras' theorem there and I can find the other side as well, can't I? Now, why should I do that is the next question. Can I prove they're similar to each other? Is what I should be trying to look at here. Okay, can I conclusively prove that these two angles are the same? Ah, I can. Look at this. Ready? Green angle here. Okay, forget the lens for a minute. Just forget the lens, right? And here's what I'm thinking. Green, blue, red. Yeah? And then green, red, blue on the big triangle. Can you see that? What? Green is the same angle. It never changed because it's the big triangle, isn't it? So the two triangles are actually similar to each other. Is what we've learned here. Okay. Now, if you're a bit like me and you feel that that diagram's just a little bit, oh, it's a bit flooded for your liking, I tend to draw them out separately. Even in an exam, I'd be like drawing these two triangles out separately, and I'd mark them out. I wouldn't mark it on the main thing. I'd mark it outside it, just so my diagram doesn't get too flustered. But here it is again, one more time. Right angle, right angle. The angle that's at E. So what's the angle at E again? Same, yeah? And then third angle, the other two angles therefore have to be the same. So what I'm claiming is 15 over 20, yeah? What we're looking for, EO, aren't we? 30, it is 30, thank you. That's why we pay you the money. Now, guys, looking. So 15 over 30 is the equivalent to what? Oh, okay, now we have an issue here, right? The issue is E to B on the small triangle is actually there. It's the hypotenuse, isn't it? So I think we should use Pythagoras' theorem to find the hypotenuse of this one. Somebody needs to be sent to H1 a long time ago. 15 root 5. Is that okay with you guys? Now, what I'm claiming is the following ratio. We're going to do the big divided by small again. Is that okay? Our usual one. All right, the hypotenuse of the big triangle. What is it? The hypotenuse of the small triangle. 15, yeah? The side that comes between the green and the red on the big triangle. 15. The side that comes in between the green and the red on the small triangle. EO, otherwise known as X. The point of the question. But once it's stored in the answer, keep it in stored form. Bring the X upwards. Bring the 15 up to the other 15. And then divide by 15 root 5. And actually, that is a question that we could have been asked. Similar triangle question, similar to what we're doing today. 15s cancel, don't they? That's just 15 divided by root 5. Root 5. And that is why we have to cover this section at the end.